Hello! Not gonna lie, this is the third video that I have recorded this afternoon. I recorded 2 videos for geometry and now this one. So I'm a little worn out, but I will do my best to try to keep it entertaining, stay energized. What is today for you guys? It is Friday. We just took the test on Wednesday. I wasn't there for that, but hopefully you did all right. We've got these notes here coming up, and if you take a look at your packet, you'll notice it's rather short. It is. Lesson 1 today, Lesson 2 when I come back and I see you. Boom, that's it. Review and test. Quiz. Right, it's not going to be that long. So, yeah. So hopefully that sounds good. So one of it through a video, one of it when I get back, okay? Also, not only will there be this video, but there will be the scanned in notes like usual. Dinkle always posts those. They're never my notes. They're Dinkle's notes. And I don't know how often you guys choose to look at those, but I'd almost encourage you to look at those because stats is Dinkle's bread and butter. He can talk stats for quite a long time. So I'm sure his notes will be pretty darn good to look at as well. So I'm going to do my best here. Dinkle's going to do his best. And hopefully the combination of these two things, you feel like you come out of this lesson knowing what's up. Okay? So let's just get to what is probability. Probability is favorable outcomes out of total possible outcomes. So, when it comes to a dice, how many outcomes are there? There's 6, but what's the probability of getting a 1? Well, there's only one on the dice. There's only one favorable outcome. The other 5 outcomes we don't care about. So the one outcome of a 1, there's a 1 out of 6 chance. Or evens. How many evens are on a dice? 2, 4, and 6. So there's 3 favorable outcomes, 3 outcomes that satisfy the requirement, and the other 3 don't. So when I say favorable, I mean like successes, right? The things that we want. And possible means, whether we want it or not, it's possible. And that's what probability is. And I'm sure lots of us are like, I know what probability is, right? You got a 1 in 6, you got a 1 in 3 shot of doing something, right? Or like the probability of guessing on a multiple choice option, right? There's 4 options. Only one of them's correct. You got a 1 in 4 shot. That's your probability. So let's think about a spinner. So Larry spins a spinner 50 times. The spinner lands on orange 20 times. Purple 5 times. So orange 20 times. Purple 5 times. Green 10 times, and brown 15 times. Okay? So what is the probability that he'll land on orange? Well, how many possible outcomes were there, right? He spun it 50 times. There were 50 different outcomes, okay? And 20 of those were in our favor, orange. So 20 out of 50, or 2/5, which is 40% when you plug that into a calculator. 2 out of 5, or 2 divided by 5 is 0.4. 0.4 times 100 is 40%. So what are the possibility that he'll land on green or brown? So this is interesting. It says green or brown. So there's 2 favorable outcomes. So we're going to add these events, okay? So when it comes to green or brown, we landed on green 10 times and brown 15 times out of the 50 possible spins, which is 25 out of 50, or a half, which is 50%. Probability, pretty straightforward for the most part. What is the probability that he will land on purple and green? Well, before it said or, this time it says and. Your spinner, you don't have a mixture spinner, right? It either lands on purple or it lands on green. It can't land on both. You can't land on something that's both purple and green. So the chances of that happening is there's no chance. So 0 out of 50 or 0%. How can you land on two different colors? It's not going to happen, right? If it lands in between them, you're going to spin again. You can't land on both. So 0 out of 50. This last one, use a sentence to describe the makeup of the spinner. How about we draw a picture? Instead of trying to describe it with words, let's just draw a picture. So here's a circle. Okay, there's a circle. What does this mean? When it comes to the 50 spins that we've had, 20 of them, or 40% of them, were on orange. This leads me to believe that, well, 40% of the spinner is orange. So a little bit less than half. So half would look like this, right? That's half. Well, it's not quite half. So something like that. If this is the center, something like that, right? A little bit less than half is orange. Going along with that, right? 5 out of 50. 5 out of 50 is 10%. I don't need that to be so thick, eh? 5 out of 50 is 10%. So 10% of the spinner is purple. 10 out of 50, or 1/5, is 20%. Ooh, 5% battery. This better not die in the middle of this or I'm going to be pissed. 10 out of 50 is 20%. And 15 out of 50, what does that come out to be? Is like 30%. Okay. Well, we know that half the spinner is purple or brown and green, right? We literally said that here. So if I drop a line down, right, this entire half, the right half, is purple and green. A little bit more of it is brown. So there's the brown and there's the green. And then that leftover smidge is purple. And hopefully that makes sense, like how I broke that down, right? But probability leads us to a conclusion there as to what this looks like. Even without seeing the spinner, I can kind of take a stab at what it looks like because of the result. Okay, so let's continue on. For whatever reason, my PDF is like backwards. I'm having to like scroll up to get to the next page. I don't know why, but I couldn't figure out how to reverse it, so we're just going to leave it the way it is. So Martha spins a spinner 200 times. The spinner lands on the letter A 62 times, yada, yada, yada. What's the probability of landing? Approximately what part of the spinner does A and B make up? So approximately what part? So just like with green and brown, together they made up 50% of the spinner. Well, together A and B make up what part of the spinner? Add them up. That comes out to be 95 out of 200, which reduces down to 19 out of 40, or 47.5%. Please reduce your fractions. just reduce them. All right, 295 are both divisible by, in that case, 5. Okay, so that reduces down to 19/40ths, or 47.5% when you plug it into a calculator. Again, approximately, so what do we do here? We added. What are we going to do here? We're going to add again. What part of the spinner, right? It's the so there's this part and this part, so add them together. In total, C and E. E is 20 times out of 200. So 94 out of 200. They're both divisible by 2. So we get 47 out of 100, which is easy to tell that that's 47%. So 47% of the spinner. So practically the same amount. Approximately what part of the spinner does B and E make up? Once again, we're going to add, because we want to know the combination of the two parts, B and E. B is 33, E is 20, so 53 out of 200. That doesn't reduce down to anything, so that's 26.5%. 26.5% of the spinner is B and E. So again, what did I keep using over and over there? Favorable out of total. How many are actually A and B? How many are actually C and E? Those are the favorable outcomes. And then the total is the 200 spins. There are 5 white socks, 9 black socks, 3 blue socks, and 8 striped socks in a drawer. Find the probability that a sock randomly selected from the drawer is blue. Well, we need to know how many socks there are in the first place. So 5 plus 9 plus 3 plus 8. There's 25 socks. So what is the probability that it's blue? Well, there's 25 possibilities, and there are 3 blue socks. So the probability of grabbing a blue sock is 12%. When you plug that into a calculator, right, all I'm doing is 3 divided by 25, and I get 0.12. Maybe you can see that there. Well, that's 12%. Okay? What about black or white? Once again, we are adding. So black or white, there are 9 black socks. There are 5 white socks. So those are the favorable outcomes, but how many total possibilities are there? The 25 socks. So 9 plus 5 is 14 out of 25, which comes out to be 14 out of 25 is 56%. What is the probability that the sock will not be striped? So there's 8 striped socks. All the other ones aren't striped. So there's 8 that are striped. The rest aren't. So 25 minus 8 is 17 non-striped. So there's 17 non-striped ones. So 17 out of 25 is 68%. One more time with all this here. The Algebra 2 class took the statistics test last year and received the following scores. 15 students got A's, 23 students got B's, 35 students got C's, 19 students got D's, and 8 students got F's. If this year we have 300 students, how many students should the Algebra 2 department expect to pass the test with at least an A, B, or C? Well, we're going to use what happened in the past to predict what's going to happen now with the 300 people. 300 students. So let's take a look at what we had before. There were 15 A's, and there were 23 B's, and there were 35 C's, and there were 19 D's, and there were 8 F's. If you add up each of these people, there were 100 students, which makes life easy. Out of 100 is nice. So there were 100 students. How many passed that year, right? Last year or whenever this was. How many passed? The A's, B's, and C's. I guess D is passing too, but we care about the A, B, and C people. So in that year, 15 plus 23 plus 35, 73 out of 100 got an A, B, or C. So 73 out of 100, well, we're assuming if 73%, whether it was out of 100 or 50 or 1,000, what we're saying is if 73% got A, B's, or C's, then we're going to safely assume that 73% are going to get A, B's, and C's now. So 73% of 300 is 219 students. Does that make sense? I mean, hopefully that makes sense. Right? We're just using it as it's a prediction. Right? If 73% could do it then, why can't 73% do it now? Okay. So on this next page is a crap ton of vocabulary. And let's answer the vocabulary as it's addressed in each problem. Okay? So there's all of this vocab. Some of these, I feel like you probably have heard of it, and you know what it means. Some of it maybe not so much, but hopefully we're decent. So this says to identify the population and sample in example 5. So let's address those two things. What's a population and what's a sample? The population is the entire collection of people from which we may collect data, while a sample is a group of individuals studied or surveyed that are selected from the larger group. So the population is what we're addressing, but you can't possibly, right? You can't possibly interview every single person from a population. So you select a few, which is your sample. So like Desert Oasis could be our population, but it would be quite difficult. Like how about we say Desert Oasis parents? As we know, every single parent has their own schedule, has a different job. Do they work night? Do they work day? Maybe they're out of town, right? We can't possibly get data from every single parent. Maybe we're asking, I don't know what we're asking, right? But maybe we're asking, I don't know. Who cares? We're asking them a question. We're doing a survey. We can't possibly ask every single parent, so we take a sample. And how about our sample could be parents of students who have Mr. Skis. So we can't possibly ask every single parent, but maybe we can address just my students' parents, right? And that's a good representation because I have sophomores and juniors and seniors, and I have the occasional freshman. I literally have every grade level. So if we talk to the parents of my students, honestly, we have a relatively good representation of the school. So let's read these situations, and hopefully you can kind of catch on to what we're saying here. A truckload of pears arrives at a fruit production plant. The plant's quality control team selects 4 large buckets of pears from various locations within the truck. These pears are carefully inspected. Based on inspection results, the entire truckload is either accepted or rejected by the plant. So our population here is the truckloads of pears. But we can't possibly look at every single pear. So our sample is 4 buckets of pears. If we like those 4 buckets of pears, you're in the clear. If we don't want your product, right? So you better make sure that the majority, right? Because if you have a lot of bad pears, if you have a lot of bad pears in a bucket, right, then there's probably a lot of them. But if there's only like a couple in that bucket, well, then there's probably only a couple in the truckload. Different types of writing can sometimes be distinguished by the lengths of words used. A student interested in this fact wants to study the lengths of words used by J.K. Rowling in her Harry Potter books. She opens a Harry Potter book at random and records the length of the first 250 words on the page. So she wants to do a study on the words used by J.K. Rowling in her Harry Potter books, but she only looks at 250 words from one page. So first of all, that's a terrible study, right? You should have looked at every book. But based on what we said here, she or he, a student, wants to look at every Harry Potter book. But only ends up sampling 250 words. Only ends up sampling... Well, you could word this a couple of ways. How about I say 1 page from 1 book? That's her sample. She looked at I keep saying she, it doesn't say she. He or she looked at 1 page from 1 book. That's how they sampled it. So that's population for sample. Keep that in mind. And it's kind of interesting because like a sample could become a population, and a population could become a sample. Like when I said Desert Oasis parents, well, what if CCSD, the entire district, wanted to have a survey of all parents? They could not possibly talk to every single parent. That would be very difficult to get in contact with them. So how about they tried their hardest at Desert Oasis? So the population has now become the entire school district, and the sample all of a sudden is us at Desert Oasis. So it depends on what the study is. Determine if the following situations describe an experiment or observational study, and why. Okay, so let's address those definitions, experiment and observational study. So an experiment is a comparative study in which the researcher imposes some treatment in order to observe a response. Imposes some treatment. Versus a comparative study in which the researcher tries to gather data without influencing the response. So an experiment, they give something to the people to watch stuff occur. Whereas an observational study, they don't give or touch anything. It's just pure observation. So something that came to mind when I was thinking of some examples for these was like a pharmaceutical drug testing. Right? I mean, they have to do tests on drugs to make sure... Let me write this a little bit nicer. Pharmaceutical drug testing. Oops, I erased my highlighter there. So like they give like a hair loss drug or something, right? A pill to like encourage hair growth somehow, right? They give it to like 50 grown men who are balding and then just see what happens, right? They are imposing a treatment and then observing what's happening. Whereas in an observational study, right? I mean, the easiest that comes to mind is a simple survey. Our observation is just like, what are your thoughts on these questions? That's not a treatment, right? When we pick people at random, we're not giving some people a drug and some people a placebo, right? If you know what a placebo is. There's no treatment to the people who are being surveyed. We're just simply asking them questions. We haven't imposed anything upon them. So, let's take a look at these situations and see if you can identify between the two. In 2001, researchers announced that children who spend most of their time in childcare are 3 times likely to exhibit behavioral problems in kindergarten as those who are cared for primarily by their mothers. And let's kind of compare the two, because one's one and one's the other. Before a new variety of frozen muffin is put on the market, it is subjected to extensive taste testing. People are asked to taste the new muffin in a competing brand and to say which they prefer. Why don't you think for a second, which one do you think is which? Which one is the experiment and which one is the observation? So we either imposed a treatment or we didn't. So when the researcher imposed a treatment, when I am observing, in 2001, researchers announced that children who spend most of their time in childcare are 3 times more likely to exhibit behavioral problems in kindergarten as those who are cared for primarily by their mothers. Did I tell a mom to put their kid in childcare and then I told another mom you cannot put your kid in childcare? Or did I provide the childcare? It was just simply an observation that, oh, there are some mothers doing this and some mothers doing this. We're just observing the behavior of those kids. There was no treatment given by the researcher. Before a new variety of frozen muffin is put on the market, it is subjected to extensive taste testing. People are asked to taste the new muffin and a competing brand and to say which they prefer. Those are treatments. It's not like we just asked people casually to come in and go, which do you prefer? And we didn't even give them the muffin, and someone like, well, I've never even had the muffin, right? It was, okay, you are given the muffin, you were given the competing brand, right? Which, we're offering, that's a treatment. So the muffins is our treatment here. Like, hey, we're giving you, right? It's sort of like, if I give someone, I mean, what's the difference between that and a drug, right? I give you the drug and you tell me what happened. Like, do you feel like your hair is growing in? Do we have like a, where a researcher can see like, oh, they can measure the hair growth, or they can see how many hairs are sprouting up out of your head, right? They can't measure your tongue, so you tell them how you like it. Nonetheless, there's still a result. You give someone a drug, a muffin, and they tell you whether they like it. They tell you whether they think it's working, right? The hair loss pill, to continue using that. So this is an experiment. All right, I'll try to go a little quicker here. I'm talking too much. Determine if the following situations describe a convenience, random, self-selected, or systematic sampling. These are easy, but let's take a look at each of these types of sampling. Random, right? I mean, we all know what random is. How about just like choose students out of a hat would be an example, right? Like if I want to sample you guys and I don't want to take a survey of all of you, I just like choose your names out of a hat and be like, oh, the first 10 names, that's random. Self-selected, maybe I said, come to me after school if you'd like to participate in something. So an example would be students coming after school for survey. Right? You're not being forced to do that. You're choosing to participate in this survey, and you're coming to me. My mom works at Purdue University, and they have a lot of research. There's like a psychology department there, and they offer compensation. And she's participating. They offer like $5 Target gift card, $10 Amazon gift card, just to participate in their psychology studies that are on campus. So she is self-selecting herself to go participate in those studies. Oftentimes it's like taste testing things. She's like taste tested beef jerky before. Like what the heck? What are my other two? Convenience sampling. So it would be very convenient for me, like, to stand outside the school and ask students to take a survey. What about the kids that are being dropped off? If I'm standing in the parking lot, what about all the kids that are being dropped off by a bus? If I'm standing out in the front doors, which is where a lot of kids walk in if they walk to school, well then what about the kids who rode the bus and drove to school, right? It's just convenient for me to stand in one spot, but I'm not really reaching every type of student. And then the last one was systematic. How about I take my roster and survey every 3 students. All right, I go 1 student, skip 3, 1 student, skip 3, 1 student, right? Every 3rd student, every 4th student, every 5th student, whatever, right? Instead of asking every one of my students, but I'm not picking you at random either, right? There's a pattern to it. So which one is which? On a hot Saturday afternoon, swirling a new frozen yogurt company decides to ask every 3rd customer. Boom, systematic. Clothing manufacturer interviews mall patron and asks what their favorite clothing store is in the mall. That's very convenient. I'm just chilling in the mall waiting for somebody. Mr. Jones decides who will present their PowerPoint presentation by putting his students' names in a hat. Random. A sports radio station has listeners calling to their question, should female athletes be paid as much as they're calling in themselves? They're self-selecting themselves. Nobody's being forced to do anything. They're self-selected. Okay, so there are different when you put data on. So that was all very wordy. Now let's try to get into the data here. Some number stuff. Okay. When you put data down on the page like this, there's a few things that you can observe. You can measure their center. And the ways to measure that is with mean, median, and mode, which hopefully you have some familiarity with that. You can measure their spread, which is their range, IQR, and their standard deviation. And you can measure their shape, which is potentially skewed left or right, or it's normal, which is often symmetric. You could refer to it as symmetric. You can see here with a left skew. So like when I hear the word left skew, this almost looks skewed. You might look at this and go, wasn't that skewed right? Because a lot of the data is to the right. It's called left skew because there's like nothing on the left. Okay? If that makes sense. Okay? So the way the shape is, the hump is on the right, but the lack of data is on the left. So we call it left skew. Okay? And you can see here that the mean is less than the median, which is less than the mode. And here they're all equal for normal. And here the mode is less than the median, which is less than the mean. So all of these things are sort of related to one another. Something, the shape, the spread, and the center are all, collaborating together. So let's talk about this right here. These guys are box and whisker plots down here. So let's talk about these box and whisker plots, okay? You don't need to draw those arrows. I don't know what I'm doing. So a box and whisker plot looks like these guys. And let's talk about what each of these things represent. Down here is the min. Up here is the max. Right here in the middle is not the mean or the mode, but the median. And this is Q1 and this is Q3. Upper quartile and lower quartile, if you will. So one of our words it's very easy for me to scroll and like less easy for you to continue flipping, and I'm sorry about that. But some things that we have just now said, some of these guys here, mean, right? That's just the average. I'm not going to get there's a billion examples of an average. I don't need to tell you, right? Average test score, average, whatever. Interquartile range is Q3 minus Q1. I just mentioned those. So upper quartile minus lower quartile. A census is the data gathering technique in which all the population is studied. So, for example, the U.S. Census. We don't really talk about that too much today. Parameter and percentile, I'm going to leave blank still. What was another one that we filled in? Standard deviation. We just said something about standard deviation. It's the typical difference between each data value and the mean. So like how far apart things are. So an example of that is you might see if politics stuff is in the news right now, you might see an approval rating is maybe Bernie's approval rating in the state of Nevada is 60%, and then you might see a plus or minus 3%. That right there is the standard deviation. It's we are telling you that our data could be off by a certain amount. So that's the typical difference. So give or take. It's standard deviation is sort of like give or take. Give or take, yada yada yada. Oh, I skipped parameter and statistic question right here. Whoops. Should we do that real quick? Sorry about that. What minute mark are we at? 40? Okay, I can probably slow down a little bit. I feel like this lesson's like long. And I'm like, oh, I don't want this video to like be super long. But we're only at 40 minutes, and I think we're doing all right. So let's take a look here. On Tuesday, well, let's talk about parameter and statistic now. Oh, I keep scrolling back and forth. I'm sorry. So there's a parameter and a statistic. Sort of like there's population and sample. These are very similar. There's a parameter, which is a number that summarizes the population, versus a statistic, which is a number that summarizes the sample. So back to my, okay, DO parents are the population, and DO, and the people that were actually asked, the parents of my students, would be the sample. Okay, so, sorry. There might be, well, let's switch gears and talk about ACT scores. There might be a number that talks about my classes, so, which you guys are a part of. There might be the average ACT scores of my class. But then there's a number that's talking about DO in general, and that'd be the parameter, the average ACT score of DO. So where one number is talking about the population and one number is talking about the sample. On Tuesday, the bottles of tomato ketchup filled in a plant were supposed to contain an average of 14 ounces of ketchup. Quality control inspectors sampled 50 bottles at random from the day's production. These bottles contain an average of 13.8 ounces of ketchup. So which one is the parameter and which one is the statistic? Well, we wanted all of the bottles to have 14 ounces, but when we sampled 50, they only had 13.8. So the 13.8 was specifically about the bottles that we tested, while 14 was the goal. Those were the parameters that we set out, right? When you hear the parameter, when you hear the word parameter, I almost think like goal. What are the parameters, right? Like what are the, like, I'm not going to dwell on that, but maybe you've heard that word and kind of think like goal or like limitations. So the goal, the limit was 14 ounces, and we almost hit that at 13.8. On a New York to Denver flight, 8% of the 125 passengers were selected for random security screening prior to boarding. According to the TSA, 10% of airline passengers are chosen for random screening. So the TSA makes a general statement saying that about 10% on average are chosen, but on this specific flight, this specific example, only 8% were. So there's our statistic. Okay, we got 2 pages left, and we're doing some number crunching. Okay? Nothing's too intense here, though. The homework, right, and these kind of problems on the test, I mean, a lot of this, it's like, do you know the definition, right? Can you imagine how quick it is going to be for you to answer some multiple choice questions about this stuff? Systematic versus convenience, and parameter versus statistic, and population versus sample. I'm elaborating on it a lot to kind of help you get in the groove as to what these mean, but once you know what they mean, I mean, you either know it or you don't, sort of thing, right? So these definitions are quite important. So I don't know if you're going to put them on a note card or not, or what you're going to do, but they're definitely worth knowing. So let's do some math here. Let's make our own box and whisker plot here with this data given to us. So use the data set below to create a box plot and describe the shape of the distribution. So here's our 5 number summary. Okay, the min. So the 5 numbers that we care about are the min, max, Q1, Q3, and median. So min is very straightforward. The smallest number is 57. The max is also super straightforward. The biggest number is 99. And the median, hopefully you know what median means. If not, it means the middle number. So when you look at all of our data, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the middle number is there's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 over here. 1, 2, 3, 4, 5, 6, 7 over here. So the number that's in the middle is 78. Not literally the middle number between 99 and 57. That's not what I'm looking for. I'm looking for, of the numbers given to us, what is the middle number? Okay. And then the Q1, Q3. Well, this is like the bottom half. And this is the top half. So what's the middle of the top half? Well, there's 3 over here and 3 over here. So the middle of the top half is 62. And there's 3 over here and 3 over here. So the middle of the, did I just say top half? The middle of the bottom half is 62. And the middle of the top half is 84. So Q1 is 62, and Q3 is 84. The interquartile range, I mentioned that before, is Q3 minus Q1. That's just what's the range between the quartiles. So 84 minus 62 is 22. And range is the range of the entire data set. So max minus min so our box and whisker plot as a result looks like this. 57 down here, 99 up here, 62 here, 84 here, and 78 there. All right. Let's do this one. I hope I think I taught box and whisker plots to 7th graders at my old school. So, I know you've seen box and whisker plots before. So just watch, if you're a little hazy, just watch this clip again, right? It's very straightforward. All right, so let's make a histogram, which is basically just like a bar graph. We need to a histogram like breaks things up in like a range, right? Like, oh, some data points fall between this gap and some data points fall between this gap. How many are in each of those sections? Well, let's find out. Frequency here. So 782 goes here. Oops, tally right here. 840. Okay, do this. I'm just tallying them up. 845 goes here. Try to beat me to it here. 811 goes here. 805 goes here. 821 goes there. 691 goes here. 765 goes here. 829 goes here. That's 5. 789 goes here. 646 goes here. 7671 goes there. 774 goes there. 901 goes there. 714 goes there. 720 goes there. 753 goes. Oops, that's going to be 5. So let's make it cross. 855 goes there. 704 goes there. 747 goes there. 770 goes there. 712 goes there. 700 goes there. 750 goes there. 799 goes there. 799. Is that 799 twice? Oh yeah. Goes there. 735 goes there. 637 goes there. 640 goes there. 779 goes there. 641 goes there. 4, 2, 6, 7. Sorry, can't count. 7, 10, 5, 1, and 1. Okay. So the way a histogram works is we like make so this it's sort of like a bar graph, like I said, but how much data falls between 550 and 600? None of it. How much data falls between 600 and 650? 4 different times there was a data point between 600 and 650. How many data points were between 650 and 669? Or 699? 2. How many fall between 700 and 749? 7. $750 and $799, 10. $800 and $849, 5. $850 and $899, 1. And $900 and $949, 1. So there's the look. Not very heavy on the math today, right? This is a good day for me to be gone. Not much for me to check here, right? I mean, you just do it. I don't know. Okay, so are there any words that I didn't do yet? Z-score. Honestly, we're going to talk about Z-score more next class, so I'm going to leave that blank. And percentile, we're going to talk about next class, so I'm going to leave that one blank. Yeah. That's all right with me. Okay. So let's look at the way these look. Let's talk about their center, their spread, and what's the other word? Blanking. Their shape. Okay? So this one is definitely... Okay, let's remind ourselves... Sometimes I have to remind myself about the skew. When more of the data is on the right, it's actually left skewed. And when a lot of the data is on the left, it's actually right skewed. To be skewed means that it's like lacking, right? So skewed means less of that. So right skew, less on the right. Left skew, less on the left. So this right here is right skewed. Should we make... How can we organize this nicely? So how about we say first ending is right skewed. The second ending is definitely... It appears more normal than anything, right? It's the larger range, smaller range. So what do we? Okay, so the people are rating a movie ending, and with the first ending, what I'm seeing, right, is that there's like a large range of opinions, but the majority being more on the negative side. But yet, for whatever reason, someone gave it practically 100%, right? But there's that box shows you where a lot of the data is, right? If you think about it, right? This is when you think about a box and whisker plot. 1/4. What the? Why does that keep popping up all of a sudden? One. Why is that popping up all of a sudden? Stop. One-fourth of the data is there. And then when we split this up, this is another fourth. This is another fourth. I'm literally... A fourth, a fourth, and a fourth, and a fourth. Jeez. So, what this is saying here is that practically 3/4 of the data is negative, while 3/4 here, or half, is fairly positive. So, when I'm looking at this, we've talked about the shape, we've talked about the range. I definitely think, with that being said, this one's definitely more normal, right? The median is more so in the middle of the data, where there's like this outlier on the first ending. Just kind of making some observations. And with that being said, I'd go with the second ending, right? I'd go with that one because it seems to be making more people happy. Despite someone giving it practically 100, I'd rather have a 90, and I'd rather have all of these people giving it like a 75 and up than all of these people giving it a 70 and down. This here looks pretty normal. What else can we say about it? What else? It's normal, remember, means symmetric. If it's normal, that means the mean is equal to the median, which is equal to the mode, right? Just as a reminder, right? The data is very central. It's very symmetric. Is there another word that we could use? I feel like, yeah. All right. I feel like we did it. This video is going to be available. It's going to be posted on Google Classroom. You can watch it again. Hopefully we have seen the whole thing. It's just under an hour, as long as the sub started it promptly. Thank you, sub, whoever you are. I appreciate you. Thank you for being there and playing this for them. You should have just a little bit of time left. I just want to recap and say, we took the test last time. Hopefully you did all right. You had this class period. Next class period, I'm going to be there, 10.2. We can maybe go over a little bit more homework problems than usual. Maybe we'll have a few more questions. I really encourage you to do the homework so that way you can come with those questions, okay? You don't have time to put it off. There's one more lesson and then we're done, okay? So please do me a favor, do the homework so that way you can have those valuable questions. And I also just want to say something here before I hit the full on hour mark, that if you've never watched a stream before, I just want you to know this is what it's like, right? If you feel like you got something out of this, if you're like, well, man, this is like practically class, guess what? It's even better than class in some level because there's a live chat and you get to ask a question immediately and I will answer it. Some of you are a bit timid or shy, or maybe you just don't have a question in that moment. But when it's on Twitch, right, it's anonymous and you can just ask away and I will answer away. So if you appreciated this and you feel like you got something out of this, you'll probably get even more out of tuning into the stream, okay? So hopefully this worked out for you. I am going to hold you accountable for this knowledge despite being in a video. We're gonna keep moving along. We're not gonna slow down. 10.2 next time. Um, yeah. And again, what is today? Today is Friday. So I'll see you after the weekend. That's when I'll be back. Okay. All right. Thanks for watching.